Thank you for that. So welcome, everyone. So it looks like we're between you and lunch. So hopefully we'll try and make this session as interactive as possible. So we know that we've got quite a few people, and we just want to not run around with the microphone. So what we're going to try and do is to use technology. And in my 20 years of working, I've always found that you should never work with kids, animals, and live technology. So I've ignored that advice, and what we're going to do, so if you've got a mobile device, laptop or whatever, then feel free to log on to this website that you see on the screen, slido.com. And as you go onto that website, what that will allow you to do is enter a code. So enter the code capital D, capital S, capital F. And that will give you the opportunity to ask any question that you want. However, again, I've learned from having a 15-year-old and a 12-year-old, there has to be some moderation. So I can see which questions are coming in, and we can then make those questions live, and you can interact with those questions as well. So if you like that question and you want me to ask that question to Marius, then you can upvote that, and you'll start to see the questions then appearing on the screen as well. So in form of an introduction, my name's John Spooner. I'm the Director of Solution Engineering at a software company called H2O.ai. Have people heard of our open source technology? Raise of hands. Excellent. Well, hopefully you're gaining great value from that. So we started in 2012 in Mountain View. We're expanding our footprint, and I head up solution engineering for EMEA. We have got a wide range of employees, of which we have 10 Kaggle Grandmasters, and Marius is one of those Kaggle Grandmasters that works for H2O.ai. So Marius, do you just want to give a quick introduction to yourself?
First of all, thank you very much for your interest in this session. I work as a competitive data scientist for H2O. You might find the term competitive interesting, and it is. As you know, H2O primarily creates software solutions for predictive analytics, and my main work is to be able to make these solutions as predictive as possible in various concepts and machine learning type of problems. I've done my PhD at UCL in ensemble methods, as in how we can combine many different algorithms or approaches in order to be able to get better results. And I've done a lot of Kaggle. Kaggle is a platform that they call themselves the home of data science, and they are also hosting data science competitions. So they outsource different problems to participants, where people can compete and try to find the best solutions and win prizes. They also have kind of a ranking system. So the better you do in the competitions, the more points you accumulate. And at some point, I have been able to get #1 of Kaggle after winning multiple challenges. And I have done that a lot. For example, I may have participated in over 130 challenges. But what I really take away from this is that I have been able to see many different problems, see the winning solutions, understand what type of tricks people use to and apply on different type of problems, and I'm able to bring that back in my work and make myself better at solving these problems.
Okay, so that's a really good background into what Marius does with regards to Kaggle. What looks fantastic is I am surprised at how many questions have already started to come through and how many people are voting. So first of all, thank you for your interaction, and keep that going as we go through this particular session. I always have something prepared, so I had a whole list of questions that I've prepared, and I'm going to go straight into some of these questions, if that's okay, Marius, just to start to get some interaction. So one of those questions that I've got there is, has it been worth putting all your time and effort and energy into becoming a Kaggle Grandmaster? Has it paid off, and how has it paid off?
It has, for sure. As I've said, I mean, there are two elements of it. One is what you've learned along the way and then eventually you become Kaggle Grandmaster. But the label, the title, if you want, itself, I consider it an asset as well. And I think I've been quite objective about it. So I think going through that process of getting this, winning multiple competitions and getting this achievement means that you've learned a lot of tricks which can help you to make better predictions. A lot of this on different problems, image classification, NLP, sound, standard tabular problems. You learn different feature transformations, different algorithms and techniques. You learn to avoid traps like leakage and find mistakes in the data. Many of these skills are transferable in your job environment as well. You're able to make better predictions and solve various problems. So going at the same time, being a Kaggle Grandmaster means that you have exposure to the platform of Kaggle. You know the different channels, and that's extremely important. This is a very open community. If there is any questions, if there are any questions out there, you can get answers very easily through these channels. It's still one of my main channels to getting information about anything I might have questions for. Obviously, is the fact that I have proven I have been able to do well in a competitive environment. This gives some credibility to what I do. So it has helped me professionally as well, to tell you the truth. But yeah, it's the learnings, it's the brand itself, it's the people you've learned along the way, is to have access to all these channels. Yeah, it's the whole package.
So obviously you're what, number 4 in the world now with regards to Kaggle. So does that pay its bills in complete isolation? So does it pay for your mortgage, all the winnings that you have from a competition at the present time point?
No.
No. So
no, but,
so one of the questions that have come in.
But this was also never my goal.
Okay.
Yes.
Okay. So the key is that obviously Marius has to balance the work that he does for Kaggle, but also that he does work that he gets paid for H2O. So how do you manage your time between a full-time job? And trust me, Marius doesn't work full-time. He works far more than full-time, given the number of messages that I receive after midnight from Marius. But how do you manage your full-time job and Kaggle competitions?
Well, I think a trick that I've done quite well is to convince the company that also, some of the stuff I do on Kaggle are, transferable to what we do, for example, at H2O. And there are there's a lot of correlation because, for example, the company tries to produce software that's able to solve multiple different machine learning problems and in an automated fashions. So being able to get exposure on Kaggle, which is a platform that, if there is something new that comes out there, people are going to try it, and they have a lot of incentive to also share what they're doing. I think Kaggle has also gamified a bit the sharing process, and it gives you sort of, again, points, credits for you sharing. At the same time, if you're a researcher, you get a lot of credibility by testing your methods in a competitive environment. So if there's, what I try to say is that if there is something new, there is very high chance that it will appear on Kaggle, and then you can take this, and if it works, you can also incorporate it into your work, and it's very relevant to what I do, obviously.
And I think that links down into the next popular question that we're seeing on the Slido. Is we spend a lot of time working with customers directly and looking at their real-world data science problems and challenges, and you're trying to replicate that in the work that you're doing with Kaggle. And one of the things that I see, and you see a lot, is this whole problem of imbalance with regards to data sets. So there's a question here that says, how do we deal with, or how do you deal with severe class imbalance in a training data set. So are there any tips and tricks that you could give the audience with regards to that?
This is a question I receive often, and this and normally the response I give here is not liked a lot, because from my experience, depending on I think how you deal with it largely depends on what you try to optimize. Because, for example, if you try to optimize for getting as close as possible the right probability in a classification problem, then you normally don't want to change anything in respect to your original relationship between your classes, even if you have some which is not very infrequent. I have rarely seen usefulness in doing that. Now, if your metric is more like in the form of, let's say, area under the ROC curve, where you would care more about the ranking rather than the actual, for example, probability output, like the probability to be sensible, real, as close to the reality as possible, then I've seen that different upsampling or downsampling techniques, putting higher weight on your minority class, they tend to be, they might be useful. Even artificially generating more data for your weaker class with techniques like SMODEs, they may add some value. But in principle, even some of the tools which are very popular out there, for example, like LightGBM, when they have special modes about imbalance, they normally just upweight the minority class.
Okay,
Yes.
that's cool. So H2O as a platform was very much built for big data problems. Mm-hmm. So how do you take data, distribute that across clusters, whether a Hadoop cluster or a Spark cluster? So you're used to solving big data problems. But a question that we've got here is, what approaches do you like for small data problems? So I don't know how small is with regards to that question, but are there any specific approaches you take there?
I mean, yeah, and I also think people may have different definitions for what small is, but obviously when you have small data, you are worried about, it's easy to overfit with some of the most complicated models and algorithms out there. So my approach is normally to try simpler things, and irrespective of sort of my Kaggle tenure, which is purely based on maximizing predictive performance, I put a lot of effort to make certain I understand what's happening on those smaller data sets. So I would prefer linear models in principle, or decision trees, or even very shallow versions of some of the more complicated models. I would normally try and do generally validations with as large sizes as possible, and I would focus a lot on reducing the standard deviation of my actual metric, what I test against in my validation methodology. But in principle, I put a lot of thought into this, and I will resort to simpler models in general.
So you're speaking specifically about algorithms there, in terms of linear algorithms. But
so I think the same goes to the feature engineering. I will normally not try to do extremely smart things. For example, I will not try to use targeted coding as feature transformation. I would. I might use simpler, like transformers, which are less prone to leakage and overfitting. Okay. I will not try to create also, let's say, many dummy variables that will increase the dimensionality of the data set a lot. So in everything I do, I will do it in a much more reserved fashion on smaller data, because I'm concerned about overfitting.
Okay, cool. So if we move then back out from the small data space into the algorithm space now, mm-hmm. We see definitely the customers that we're speaking to, the XGBoost seems to be the go-to algorithm for a number of customers. And the question here is sort of on the same lines, is that really looking at, why do you think XGBoost is so dominant in the Kaggle sphere? Have you got any thoughts at all about that?
I would say it's both, like XGBoost and LightCBM. I would probably generalize that to gradient boosting methodologies, which are quite extreme. I think there are various attributes that make these algorithms quite popular. For one, they have done very good job at parallelizing them. So they're quite fast. The engineering that has gone behind is very good to make these models very scalable. Second, generally, decision tree type of methodologies have a way of handling, for example, they're less prone to be affected by outliers, for example, because they tend to cap everything based on the splits. So they, out of the box, they normally can give you better results without much pre-processing. You don't need to worry about stuff like scaling the data. They explore interactions like out of the box, which quite often are important to get better results. Then is the whole idea of boosting, where you make every new, because it's an ensemble of models, and you make every model trying to minimize the error that the previous model produced. So this whole notion of progressively building the algorithm depending on the error of the previous iteration tends to work really well in practice. Then also a lot of the data tend to have nonlinearities, so most real-life problems. As I said, they have done an extremely good job also in engineering. So all these together, they made it a very good selection.
Okay. Yeah. So you're very open in terms of sharing your methodologies with the community.
I try.
Yeah. So in terms of that, someone's asked a question have you got any top tips for data pre-processing and feature generation? So have you got one tip for data pre-processing and one tip for feature generation, maybe?
For pre-processing, again, I think what I can say is that I treat everything as a hyperparameter. So how I will replace missing values. For example, will I take mean, mode, median? Will I treat it as a separate category, just as missing, so that algorithms can handle it? Do I scale or not the data? What type of scaling will I use? I normally don't have preconceptions, or I don't make huge assumptions about the data. I tend to try many things and actually see what's working best in a very experimental environment. So as such, I don't think I have a specific trick that really gives me the edge. Is the fact that I treat everything as a hyperparameter. Everything it's a parameter that can be tuned. Every feature can be transformed in many different ways. Categorical feature, you can transform it with dummy coding. You can use something like frequency encoding. You can use label encoding. You can use target encoding. Then target encoding has many different variations. It could be weights of evidence. It would be just average or other type of likelihood methods with noise or not. So and you need exposure on Kaggle or other platforms and blogs to learn about all these tricks, but then everything becomes a hyperparameter of the end problem. So you need to work iteratively to find like what works best for all these things.
So I'm pretty sure that was just more than one tip. So so you've got quite a few tips there that will potentially help you to then become top of the Kaggle leaderboard, but also help you as part of your day-to-day jobs. In terms of that gap between Kaggle and solving real-life problems, clearly there is a large gap. Some of the problems that you've worked with, you've openly confessed to me, you would have no idea how you would look to productionize those results. You're very much focused on accuracy. So what do you see as that biggest gap between a Kaggle project and real-life work? And then how do you plug that gap?
Yeah, I think there are many differences, but I think the one you just pointed is one of the biggest ones, like the fact that there is no normally the implementation in mind. Like when you try to win a competition, this is like a race, right? When you run and you try to win the race. I mean, the running is a good skill to have, but it's in the real world you probably won't need it unless, I don't know, maybe someone steals your bag and you try to chase him. This is when you will put it in practice. And this is a thing. It's similar in Kaggle. It's nice to have that capability to solve these problems, but the end result is, I feel, may not be very useful sometimes to the organizer. At least not as an end-to-end solution. They can extract learnings and other things, but as in taking something which is very productionizable, I don't think so, because normally it's a process, takes a lot of time, it may combine multiple different models together. The complexity is quite high, the scoring time may be quite high, so there is a gap there. The other thing is normally the data is fairly prepared when they put on Kaggle. Normally this is something that as a data scientist or a data person, you need to spend quite some time even bringing all the data together in order to form your data sets, even defining the objectives and how to make certain that this is aligned with the original business objective. This is normally something that needs a lot of time. Other things, I guess, regard the visibility and accountability of your results, like can people sort of understand what your model is doing, that in a business environment is normally very, very important.
What about, so you've talked about deployment of models, you've talked about interpretability of models.
Yes.
What, in terms of the speed at which you deliver a platform, so the speed at which you build those models, how do you get around that as a challenge?
Yeah, I mean, I think also how well you do on Kaggle is a function of the time you've spent. So definitely putting more time. You get the chance to try more models, more transformations. You try to seize the data from different angles, and time definitely gives you a boost.
So you say see the data from different angles.
Yes.
So how do you, the question that's at the top of the moment is, what are your go-to methods for visualizing data? So clearly you've got this whole numerical structure of data, you're going to throw it into your pipelines that you've built. How do you actually visualize what's going on?
Yes.
And the key drivers and factors of the data?
Well, if the data is small, I just put it in Excel, to be honest. to be honest, and I will use all different kinds of graphs. I mean, I like to bin numerical features normally, and especially make stack bars, for example, against normally the target variable, what I try to predict. I try to maybe plot different features against time, if I have a time variable. I will try to make heat maps in order to understand, for example, correlation between features, because this helps me to formulate a better idea about how the problem works, create smarter features without spending so much time on the very iterative brute force process, or minimize that process. Yeah, I mean, just simple histograms to see outliers, and if there is something I can do for them, for example, remove the observations or cap them, depending on which algorithm I might use. I mean, yeah, these are some of the stuff I do. Normally, I don't do extremely smart things, not as others. I mean, for text, I might do some word cloud, where I might just change the color based on the words, depending on the average target value, for example, and maybe use the size to define how many times that word appears. I normally don't do extremely smart things, I have to be honest, in terms of visualization.
Okay,
yes.
Okay. So just moving away from some of the tips and tricks with regards to Kaggle, someone's asked a question specifically about how do you gain new knowledge? So what books are you reading right now? Are they very highbrow?
I normally don't read books. on data science. I mean, I do read papers, different academic papers, but I don't tend to read book. I mean, nothing comes to mind right now. I follow different blogs like KD Nugget, for example, Distill. I also follow a lot of people in social media, and I have actually found that quite
Do you want to
good.
share any of that, or
I
is it
mean,
a bit embarrassing, like
no,
my
like
Instagram?
the leaders in this space, Andrew and Hinton. You know, some of the people who you know, they evangelize data science and the innovations in this space. I follow Kaggle a lot and all the different forums and Slack channels. This is a great resource for me.
So linking back to that, actually, in terms of the Kaggle competitions, do you find them reflective of data science work in industry or academia, or balance of the both? Obviously, you're speaking to customers day in, day out. So do you see Kaggle competitions being reflected?
Some things are transferable, as I said.
Okay.
Like some things are transferable. I mean, you know, how you would do the validation, how you can avoid leakage or errors, for example, and not to underfit or overfit. Yeah, the different algorithms, how you tune them, the different feature transformations. All these are things you can learn on Kaggle, which have good applications in your everyday job. I mean, other things, as I said before, are not. They're also in academia. Again, there is some proximity, and a lot of people have actually made papers out of solutions they've done on Kaggle, because you know, they can be. Many of the problems were quite innovative. For example, I remember an interesting one where you had to basically download the whole UK Wikipedia and build a model that's using only this resource to try to find the right answer into a 6th grade science examination test, which was actually quite tricky. I mean, it wasn't just because the questions could have been like tricky, like what is not this?
Yeah.
While in your source data you have what is this?
So do you think that's your favorite Kaggle competition?
It was a very interesting one. I don't think it was my favorite.
So what was your favorite then?
Probably the first one I've won. It was called Acquired Value Shoppers Challenge. It was an interesting problem in the recommendation space. So you have to, given that a customer was sent a coupon and they bought the item represented on the coupon, will they now buy it again? So was that coupon enough to create a habit for you buying the product? And that was very relevant to what I was doing at that point, because I was working in dunnhumby. It what made me a Kaggle master at that point, gave me the label. I mean, it helped me professionally as well. I had very good collaboration with a person called Gerd Jacobius. He was a great data scientist. I've learned a lot from him. Even my thesis borrowed ideas from this, and it was actually what started my PhD. So all this together, an interesting problem to solve, it was made it in. Yeah.
Awesome, awesome. So I don't know if anyone has had the pleasure to meet Marius in a customer meeting, but the first time I met Marius, and he was presenting some technology to a customer, he brought out his laptop. And this laptop, well, I'm surprised he hasn't got back trouble. It's the biggest laptop I have ever seen in my life. It's an Alienware, is that correct?
Yes.
Yeah, it's absolutely huge, and I'm pretty sure smoke comes out of it occasionally. But underneath the covers, obviously you're doing coding on that. So one of the questions is, what is your everyday coding setup on your massive laptop? Jupyter or an IDE?
So,
if so, which one?
Yeah, Jupyter, I use that a lot, and Spider, I use that a lot. For RStudio for R, and for Java, I use some Java as well sometimes, but I cannot remember the name right now. Not NetBeans, I use something else. The name is can't think of it right now.
Okay, no problem
it's
at all.
But yeah, yeah, the typical tools. I don't use something that most people don't.
So what you've done really well is articulate the data science skills that you've been able to pick up from Kaggle. So your coding experience, how you then build features, how you deal with imbalancing, etc. But you're not just a one-dimensional individual. There's other skills that you've had to acquire being a data scientist, especially now working at H2O, being a customer-facing data scientist. So what skills have you picked up over the last 4 or 5 years as a practicing data scientist that you weren't able to pick up from Kaggle? And how have you done that? And how have you thought to develop those skills?
Yeah, that's a good question. I think the ability, one thing that comes out as important from my experience is the ability to convey complicated concepts into generally to be able to translate complicated concepts into simpler language so that the businesses can use them. That has helped a lot to bridge the gap between what sometimes data scientists do, which can be deemed black box, and something that the business can consume. At the same time, I think you need to, as I said, solving you need to have also good presentation skills. I think that's quite important. I mean, you still need to put good PowerPoints, again, to help you convey those messages, making your points clear in regards to how data science can really help you get better results on specific problems. Obviously, good communication skills in general. Ability to troubleshoot problems.
So quite a few, and I think you really highlight that point of if we're just doing data science in a isolated environment, then people aren't going to gain that trust to adopt the work that we're doing. So we need to have that ability to communicate our results in a very clear and concise way. So one question here that I really should ask, but it'd be interesting to see what the answer is. So the big 4 companies. So I don't know if this is the big 4 management consultancies or the largest companies in the world. But do you get contacted by the big 4 companies a lot? Just say yes or no. I don't know. I don't need to know what the conversations are.
Before, like PricewaterhouseCoopers, KPMG are these. Sorry, I'm not. I don't know which one because I've heard this term of big 4 in various. I get contacted. I mean, I think Kaggle has helped on that. It's and through its promotional channels, through different means, I do get contacted.
Okay. So one of your jobs at H2O is to use some of that knowledge that you've built in terms of Kaggle competitions and embed that into our products. And you're the one of the recipes that you add input into is the time series recipe. So you've done quite a lot of work with regards to improving our forecasting capability. So there's a question here that says, would you prefer ARIMA models for time series forecasting or LSTMs? What would you say?
Depends on the. I think depends on the. I don't have a preference because to me it's a matter of trying which one of the 2 works best. Just trying it and see which one works best. So I don't. I think. Again, and assuming ARIMA, you mean something which can be quite parameterized, so you can work a lot on trying to find, for example, the best auto-regression level, the right integration. And deep learning models also generally get to improve a lot at the same time. I would give probably LSTM a slighter edge based from my experience right now, but depending on the problem, it can be either way. I generally don't like to have favorites. when it comes down to this. Like, I prefer to just try and see which one works
and let
best.
the data decide which is the best algorithm given the accuracy.
And again, ARIMA, how you parameterize, how much degree you put, for example. Again, it's a parameter in itself, right?
So how old were you when you started Kaggling?
24, 25, let's
25. So how many people were younger than 25 in the audience? Okay, younger than 20. Okay, so how early can aspiring data scientists get involved in Kaggle?
So I think we had also one person which was 14.
Wow.
And I know Michael, and we won a competition together. And it was quite funny because when we won, they could not give him the money because he was underage. But I think also it has helped him. I think, yeah, it helps him. You learn a lot. Obviously, if you have a passion for the data. So I think you may start as early as you want, really, because I think there are not huge constraints to enter the data science domain. I think and you don't need to aim for immediately for the top. This will never happen. No one started like that. And you only need a laptop, basically, which is a fairly okay laptop. So, and right now also, Kaggle provides its own machines, so you don't even need to have your own machines. And this can work even for problems outside Kaggle. So you can use it for your projects. So there are not really much constraints right now. I think as early as you can.
So you've met quite a few people through Kaggle, and you've built a really good friendship network around Kaggle, and you've got your favorite Kagglers and your people that you probably spend more time competing against than with. So is it better working with teams or alone? I know you're very vocal in terms of how the Kaggle pointed system works. So do you think it's better working with teams or alone?
It's definitely better working with teams. I consider data science a team job, a team sport, sorry.
Yeah.
And you will clearly, and that's because of how diversity in the solutions can yield better results. And it's not just that you can also generally divide the space of what you need to do. So someone will say, I'll focus on feature engineering. Someone else may say, I will focus on a specific type of algorithm. And so you can cover more ground more quickly. But at the same time, because different people see the problem from different angles, this by itself is able to yield diversity in your predictions.
And is there an optimal size of those teams, would you say? Or the more the better?
No, I think it might get, because you need to have some management skills too. And normally someone assumes this role, intentionally or not, when you form these teams. Yeah. I think it can get out of hand if the team is a bit too large. And sometimes these collaborations may be short and you may not know the people very well. I would say 3-4 people seems to be a good number.
Okay. So there's a question here that probably talks about usability and creating standard templates to solve more and more problems. So is there the best way to build a pipeline that can be used for multiple Kaggle competitions?
I think yes, and I do this. Actually, this is one of not tricks. It's a good tip if you want. That at the end of every competition, I go through the forums and the discussions, like the kernels, and I copy every code I find useful, and I create a personal library for all these things, and I might reuse them when I see a similar code. And obviously, yeah, I've built pipelines to do certain actions, which I repeat quite often in a fairly structured fashion. But this is something that has helped me well. I mean, one of my best skills, to be honest, is copying what the others are doing and integrating it to what I do. So that's it's a good thing to do, to create a pipeline after seeing various solutions, see what most people do.
Okay.
Yes.
Okay, and then just want to, I think, end off with is one that is specific to this application. So any idea what the correlation is between how early a question is asked and how many upvotes it gets? Any ideas on that one?
Yeah,
I'd imagine it's probably quite high.
Yes.
Yeah,
yes.
given that it's got more opportunity to get those upvotes. So I'll just switch
yes.
that one. So I'd like to just finish off by thanking Marius, and thank you all for your interactivity. We've got a huge amount of questions here that we haven't had time to. We haven't gone to that magic list of questions that I had just in case that everyone was shy. So a round of applause to Marius for answering that.